did you get?
9 squared.
So I'm asking to square E times B. What do you
X squared times x squared plus 2.
Good.
Okay. Or that, dx.
So without this, it's undoable, yes?
What's dy over dx?
dy over dx.
No, but I thought, do we have to do a chain rule or something?
Yes, we did. That's what the 2x is, the change. So if I said set up the integral, you're there, you set it up. If I said finish it, I just want you to see something. You don't have to write this, relax. Can you see this is x to the 4th plus 2x squared
Yeah.
plus 1?
Yeah.
X to the 4th plus 2x squared plus 1, factoring. X to the 4th plus 2x squared plus 1,
Squared plus
factoring.
x plus x squared plus 1 times x squared.
Yeah.
4x squared plus 1 squared. Square root of that. This was the one that you could have finished. We're not going to finish it, but you could have just written as x squared plus 1. We haven't integrated anything yet. You do have to integrate x squared plus 1 and plug in the values and you'll be finished, yes? Just wanted to have you think about that. Good, right? Trying to get as many as I can. That first one was clear, which form you were going to use.
This one.
Sorry, this is equals 4y cubed. It says from 0, 0 to 2 square root of 3, 3. So it's really not clear in this question, and they're giving you no hints as to which dy dx or dx dy, which one you're going to find. So I'd like to just have you think about this. What do you think? Or do you think
All that.
might be better for this question? Ruth,
I think the dx dy.
why do you think that?
Because it's easy to take the square root of that side and get 3x and then divide by 3.
So the square root of that side is not 3x. What is the square root of that side?
2/3. Oh, that side? Sorry. Those things.
What is the square root of that side?
Plus
It is
or
not
minus.
3x.
Plus or minus 3.
Yes, it is. Stop making that error. It's not okay to make that error. So if you did the square root of both sides, you're going to get a plus or minus involved in this question. Probably not the way to go. It's probably better to solve for y because of the plus or minus. If you're solving for y, there's no plus or minus. Gavish? Now, if you don't know that there's a plus or minus, there's no problem for you. But there's a problem. So I'm assuming you divided, yeah?
Yeah.
You have 9/4, yeah?
Yeah.
And then you're making this y, so what does this become?
Cube root.
Of?
9 squared.
Right, so I'm going to write it as 9/4 to the,
1/3.
yes. And then x to the,
2/3.
just so we can get this done in the next step. You see what I mean?
Yeah.
Why did I want to have this separated? Yes,
When you take the derivative, you don't see it as part of the x.
yes, no chain rule involved, it's just a number. So we can find dy dx now. What is dy dx? It's just a number. Yeah.
Is it 2/3 x over 2/3 x to the negative 1/3?
Yes. But there's more.
Times the 9/4.
Yes. It's minus 1/3. I think you said 1/3. Are we there?
Yeah.
Okay. So far so good? So let's find this. Now that we are finding dy dx, of course we're going to use a form that ends in a, that ends in a,
Yes.
x was right. This is a dy dx dx. Square root of 1 plus that thing squared. Gabish? So that thing squared is 4/9. 9/4 to the 2/3. Somehow we're going to be able to combine that stuff. We're going to make a little room. And then x to the, yes. So I don't like how it turned out, I need to extend my square root. We always want to be clear about this. Okay. As x goes from,
0 to 2 squared.
yes. So once we decided on dx, we had to use the x values. That's the setup, yeah?
Mhm.
Can you see that this, we're gonna simplify somehow?
Yeah. It's the 4/3, it's,
So maybe we could write 4/9 to the 1 as 4/9 to the 1/3 times 4/9 to the,
2/3.
can we do that?
yes, you want.
And then we could write that over here. You see the,
Yes.
Oh.
good. So, this particular question now, the form that we're in, since it's 1 plus that, I don't think it's gonna be very integral, it's not a happy integral, we can only get to the point where we set it up. But we set it up. Any question on this? Had we done it the other way, it still can be done, but there's gonna be a plus or minus involved. And then when you square the minus, it becomes plus anyway. Would have been okay. Question, anybody have a question? Yes. By the way, excuse me, before I take that, if we did the other one, and I didn't want to shy away for that, and then bring you back to it, had we done the other one, it would have been integrable directly. We wouldn't have to stop and say, I can't do it, I'll do it on my calculator. It would have been done, could have been done directly. Go ahead.
I'm not able to, I don't know how to integrate that.
I'm sorry?
I don't know how to integrate
I don't know how to integrate that, that's what it says. We're on the same page. Yes.
What was the point of making it 4 equal 4/9 to the 1/3?
So that we can make it, maybe it was gonna be integrable, it's gonna end up being 4/9 to the 1/3, yeah?
Yeah.
X to the minus, maybe it would have been integral and it would have been a nicer form than having this times that. Since it's 4/9 and 9/4, I actually want you to be able to see the arithmetic. Advanced arithmetic. Okay. I have another one like that, and then I like to do parametric, I know we're going pretty quickly. I'll go to this. This is gonna be obvious. Hi, Anita.
Can you see it, Moshe?
Why I say this one's gonna be so obvious? Because
says one.
that's the first reason. Clear as day. You should do it that way. What's the other reason?
It has one,
That was the first one. You got that one?
X equals.
Yes. And if I said to you, nah, I really want to have dy dx, solve it for y, what would you say?
I don't want it.
You can't. There's something in this question I need for you to see, so we're going to push through this question rapidly. Stay with me. Ready? We have to find what dy.
Yes,
There's a place to make an error here. Not here. This is what? Done. That was the easy one. There's a place to make an error right here. Please find that part of the derivative. You have 20 seconds, and it should only take you 3. Just find the derivative the second time. So, you done?
Yeah.
Did you start? Okay. Anyone know the error? There's no change. That's the error.
Try to do like the quotient rule, but like you just make it a negative exponent. And then
What's it?
y squared, 1/8 y squared equals 8y.
That's wrong.
That's wrong.
That's the error. Yes.
So that's what I was
I was
saying.
gonna say, you bring the code, you shouldn't bring the 1/8 up.
So what should you say?
Just see 1/8 times y to the negative half.
That's what you
Negative
should say.
2.
And it's not having that negative 2 exponent. No chain rule, it's just number times the derivative of y to the negative 2. And that derivative becomes minus 2 y to the, so in fact that term becomes
Negative 1/4.
y to the negative 3, yeah? Or 1/4 y to the 3.
Okay.
So that was the first track, first place to make an error, and you should see that. Don't think of it as 8y squared, it's not. So now let's go to our integral s from 1 to 2, square root of. This time it's dx dy quantity squared, so I'm just going to put that in this, but we didn't get to the point of this question yet. Times,
dy.
heck, we're going to finish this question. It looks like, how the heck are we ever going to integrate this? This is a specially engineered question.
Eric.
Somebody outside. Somebody's stomach was rumbling.
That too.
So I'd like us, this algebra, to square this quantity. When you square quantity, it's not full. It's not first times first, last times last, annoying. Let's first do first times first again.
1 and 6.
Let's do the last times last again.
60 y to the 6.
And what about a sum?
Plus.
And now there is an outer and an inner. It's very nice, however, with the outer and the inner, because you have a y cubed on top and a y cubed on bottom. So what is the oy? A whole oy.
Negative half. Negative half.
It is.
Oh, yeah.
You end up with minus 1/4 and then minus 1/4. So I'd like you to please note, we there, everybody?
Oh, that's awesome. Okay, that's good.
I'd like you to note that there are like terms inside the square root, the 1 and the minus 1/2. Combine and then you get plus 1/2. I'm going to place that plus 1/2 in the middle. So that you can recognize something. Here's the key on this question. This expression looks almost the same as another expression that we have on the board. Almost exactly the same as another expression. What other expression?
What?
Y to the 6 plus 1/2
That whole
over
expression.
16 y cubed 6. Almost the same as another root.
Y to the 3rd plus 1/4 squared.
Oh, that.
Why would it
We're
be?
answering a different question again. I said, what other expression does this one look almost exactly the same as? Ben?
I thought you got it.
That one over there.
That one.
It does, almost look like it. And that one is the same as that one. So what must this be the same as? Plus?
Justin Lish to the main office. Justin Lish.
In other words,
This is a reminder to those students, juniors and seniors who are planning to take the Jerusalem Science exam. They're scheduled for tomorrow, Tuesday, period 10, in room 24. If you have any questions, come to the office.
and of course you can take the square root of something squared, put stuff inside, and integrate. I'd like you to please finish this.
Jamie Jacobson and Hannah Schwartz to College Guidance.
Have a great day today. We didn't get to the parametric.
What's going on tomorrow?
What's gonna happen?
Alex Klein
And then
and
you lose
Amy
how many?
Lobster to
4 of
College
you,
Guidance.
5 of you?
No, like 9.
Wait, 9 of you?
One?
Yeah.